Everybody, Mr. Oglesby here. So today we're going to be talking about dimensional analysis. Before we get started with dimensional analysis, first off, hopefully y'all are all doing well. Wish I could see y'all's faces in person, but here we are. And second of all, there are a couple things that you're going to need for class today. First off, you do need to make sure you've got something to take your notes on, be it pencil, paper, or if you're just using some kind of Google Drive, that's fine, but make sure you're ready for the notes. The second thing you're going to need is you're going to need a calculator. All right. I do suggest if you've got one, some kind of graphing calculator like a TI-83 or TI-84. But if you don't have that, a scientific calculator works. And again, if you don't have that, then of course you can use your phone. So I do suggest you have a calculator as well. All right. So what is dimensional analysis? Dimensional analysis is basically a tool that we use in chemistry, and it's also used in things like physics to convert from one thing to another. It's one of the best tools that have ever been created for doing this. Why? Because it basically takes that entire conversion and it breaks it apart into little bitty pieces. Okay? Well, those little bitty pieces are what we call conversion factors. All right? Conversion factors. Well, what is a conversion factor? Well, you can kind of think of it as this equals this. Okay? So an example I like to give is a dozen. Well, if I asked you what a dozen is, you would immediately be able to tell me it is 12. If I asked you a baker's dozen, most of you know that it's 13. A pair would be 2. Well, those are all conversion factors that we use in dimensional analysis. Okay? So what we're doing is we're actually looking for the little pieces, and we're going to put all those pieces together to get our conversion factors kind of going along. All right? Until we eventually end up with the answer that we're looking for, whatever we're trying to convert to. So, how do I use dimensional analysis? Well, there's some steps here. So the first off is you do need to figure out what you know, right? You always start with what you know. Now, sometimes you're going to be given a bunch of data and you have to figure out what you actually know from all that data. But a lot of times that extra data is just conversion factors that you're going to use, okay? So that's the first thing you do. You figure out what you know. The second thing that you're going to do is you're going to actually give that information and you're going to start to set it up. We use what's called the railroad track, or even I call it, we just recently started working on this, and it's called the gift tag method. Okay, so dimensional analysis is all about going from something to another thing. Well, it's called the gift tag method because, well, you put a gift tag on something and it goes from and then to on top of that, right? Same thing. With the railroad track, we have another little saying that we'll use. So we're going to set it up. After we set it up, we're then going to place all those conversions in a row. And then once we've got all those conversions in a row, we should end with what we're looking for. So how do I do this? We're going to start with some stuff that's actually simple for y'all. Y'all have already learned about metric conversions. Y'all could probably do this much faster using your metric conversion methods that we used earlier that I taught y'all 2 classes ago. But this method, the reason we're going to show you dimensional analysis here is so that you can go back and double check using your other method. All right. So here it says I have 23.9 kilometers, and they want us to convert that into meters. Okay, so 23.9 kilometers, and they want us to convert it into meters. Okay, so what do I do? Well, the first thing that we did was we look for our known. Well, we know we have 23.9 kilometers, right? What you know is what you start with. So we start with what we know, 23.9 kilometers. And then we lay it out. Now, it's called the railroad track method as well because you kind of lay it out as kind of one side of a railroad track. So, next thing, I ask myself, is kilometers what I'm looking for? Okay, well, my question asks me for meters. Since kilometers is not what I'm looking for, I like to say drop it low. Okay, so kilometers, you drop it low. Never bring the number, just the unit. Why? Because we're canceling that unit out. We don't want that unit. It's not what we're solving for. So we're canceling it out, right? Just like if I took the number 2 and divided it by itself, they cancel out, right? It just turns into a 1. So that's what we're doing with dimensional analysis. We're actually canceling things out until we end up with what we're looking for. Okay. Well, I'm trying to go from kilometers into meters. Do I know of a conversion factor to go from kilometers into meters? Yes, I do. I know that for every 1 kilometer, there is 1,000 meters. That's a conversion factor I know. So that puzzle piece, this conversion factor, it's what I'm going to use to convert from kilometers into meters. So how do I do that? Well, just like with a gift tag, you have your from on the bottom and the to on the top. So I'm going to meters and I'm coming from kilometers. So to on top, from on the bottom. Now what do? Well, I put my conversion factor in there. I know that I have 1,000 meters for every 1 kilometer. Okay, well now let's think about it. Is meters what I'm looking for? Yes, meters is what I'm looking for. So because of that, I can actually go ahead and solve it. Now, the nice thing about dimensional analysis is once you're done, the thing that you finish with is always the unit that you just write on the end of your answer, because that's where you wanted to be. That's where you were trying to stop. So I have 23.9, and I'm going to multiply. You can kind of think of these lines as kind of like a multiplication symbol. Multiply it by everything on the top and divide it by everything on the bottom. So I have 23.9 times 1,000 divided by 1. When I do that, I'm going to get 23,900, and then I put my unit on there, meters. So that would be my answer. So what I want y'all to do right now is to try to pause and do this next problem. All right, so go ahead and pause your video, work through this problem, and then we're going to walk through it. All right, so I'm assuming y'all have paused it, so let's actually work through this. So I have 4.7 liters, okay? I'm trying to go from liters into milliliters. And again, I know that y'all could do this quickly using your metric conversions that we taught you earlier, but let's go ahead and do it the dimensional analysis way. So first thing I do with dimensional analysis is think about, what do I know? Well, I know that I have 4.7 liters. So we always start with what we know, 4.7 liters. Okay? And then I ask myself, is this what I'm looking for? No, it's not, right? The question asked me to look for milliliters. So since that's not what I'm looking for, I'm trying to get out of it. I'm trying to leave that because, again, it's not what I'm looking for. And that's, again, canceling out that unit. And I do suggest you always cancel it out. It just kind of keeps it tidy. It makes it a little easier to figure out where you are. So I canceled out my liters. Now I'm going from liters to what? Well, I'm trying to go to milliliters. Do I know of a conversion factor? Well, thinking back on what we know about metric conversions, yes, I know that I can go from liters to milliliters. I know that for every 1 liter, there is 1,000 milliliters. So can I use that? Well, yes, it's a conversion factor, right? I can go from liters into milliliters using that conversion. For every 1 liter, so I'll put 1 by liter, I have 1,000 milliliters. So that number went there, and this number went here. Okay, now I ask myself, is this what I'm looking for? Yes, it is. Since it's what I'm looking for, I can go ahead and solve it. So again, we multiply by everything on the top, and we divide by everything on the bottom. So 4.7 times 1,000 divided by 1. That's going to give me 4,700 milliliters. Now, let's try one that's a little more difficult, because right now, so far, we've only had one step, right? Well, you're not always going to have one step. Sometimes you're going to have to make multiple conversions along the way. So how do I do this? It says convert 27 days into milliseconds. And they do want you to write your answer in scientific notation. So how do we start dimensional analysis? First thing we do is we start with our known. And we know that we have 27 days here. Since I've got 27 days, I know I can go ahead and make that conversion. So start with the given, start with the known, 27 days. A straight line there. Okay, so I have 27 days, and I ask myself, is days what I'm looking for? Well, no, it's not. I'm looking for milliseconds, right? So I look at that days, and I have to cancel it out. So days on the bottom. So now let's think about this. Do I know of a conversion to go from days into milliseconds? No, I don't, right? I don't know that. I don't know that off the top of my head. So let's think smaller. Well, actually bigger, right? Because we're going smaller, right? So let's think, what's next? Well, if I don't know milliseconds, something that's a little bigger than that would be seconds. Do I know how to go from days to seconds? Well, no. Okay, so let's keep thinking up. What about days to minutes? No, not quite. How about days to hours? Yes, we do know how to go from days into hours, right? Days into hours. I know that the conversion from days to hours is there's 24 hours in one day. 24 hours in one day. Cancel out those days. Now, I ask myself, is hours what I'm looking for? Well, no. Again, my question's asking for milliseconds, right? So again, I have to cancel that out. So hours. Okay. Cancel out hours. Do I know how to convert from hours into milliseconds? Well, no, I don't. Do I know hours into seconds? Well, no, probably I don't. Do I know hours into minutes? Yes, I do, right? So I know that to go from hours into minutes, it's 60 minutes for every 1 hour, right? Now, I ask myself again, is minutes what I'm looking for? No. If no, we drop it low, right? Because we're canceling it out again and again and again until we get to what we're looking for. So hours into minutes happened, but minutes is not quite what I'm looking for. Okay, so now let's think. Do we know how to go from minutes into milliseconds? No, I don't. Do I know how to go from minutes into seconds? Yes, I do, right? I know that I have 60 seconds in 1 minute. Is seconds what I'm looking for? Well, no, it's not. So we go one more step. Seconds into milliseconds. Do I know that conversion? Well, I know that seconds is my base unit, and I know that milli is that milli on King Henry died by drinking chocolate milk. So I know, just like above with that 1 liter for every 1,000 milliliters, that I have 1 second for every 1,000 seconds. Milliseconds. Is milliseconds what I'm looking for? Well, yes, it is. So now we can solve it. So we would take and we would go 27 times 24 times 60 times 60 times 1,000, and then we would divide it by 1, and then divide again by 1, and divide again by 1, and divide again by 1, which we know they don't matter if it's just 1, right? And then when we do that, we're going to end up with the number that is 233280000. Okay, well, now you see why I wanted you to write it in scientific notation, which is 2.3, if we do our sig figs, times 10 to the 9th power. How do I know 9th? Because I took this decimal that was here and I moved it until this number was between 1 and 10, which was 9 times. So I get 2.3 times 10 to the 9th milliseconds. This would be my answer. Now, we're actually not going to do these next two. So we can go ahead and cross those off. You'll actually find that they are not on the notes that we gave you. But we are going to do this last one. So I actually want y'all to give this one a try. Okay, so I want you to pause your video here and give this one a try. Okay, so I'm going to assume that you've paused it and you've given it your best shot. Hopefully you've gotten the answer, but let's go ahead and work through this problem. So here's the question. It says the price of a ream of paper is $4. There are 500 sheets of paper in a ream. If a sheet of paper weighs 0.5 ounces, what is the price of 1 pound of paper if 16 ounces equals 1 pound? Okay, well, remember how we're supposed to start dimensional analysis? We start with our known, right? Well, there's a lot of knowns here, right? So what I need to do is I actually need to go ahead and list out everything I know. Let's do that. So first off, they say that the price of a ream of paper is $4. That's something I know, right? A ream is $4. So 1 ream equals $4. Okay, well, what else do I know? So let's keep reading. So we've used that first one. It says there are 500 sheets of paper in a ream. Again, something I know. 1 ream equals 500 sheets. Okay, keep moving. So we've used that one and this one. It says if a sheet of paper weighs 0.5 ounces, again, something I know. So 1 sheet equals 0.50 ounces. So we used that, and we used that. And then the question is, what is the price of 1 pound of paper? So what we're looking for is, what is the price of 1 pound? So what is the price of 1 pound? Well, they also give us this conversion factor here. So there's 16 ounces, and that equals 1 pound. So I've got all this stuff. So how do I know where to start? What is my known? What is the thing that I'm going to start my dimensional analysis with? Well, what you're trying to start with, what you need to start with, is the thing that has your known and unknown attached to one another. Because really, my question is, what is the price of 1 pound? So I start with 1 pound and I end with my price. So let's do that. We start with 1 pound, 1 lb. And I ask myself, is a pound what I'm looking for? Well, no, I'm trying to get into money, right? I need to figure out how much money it costs. So pounds gets canceled out. Now, do I know of a conversion that goes from pounds into dollars? Well, no, I don't, right? I know that there's 1 ream in $4. There's 1 ream in 500 sheets. There's 1 sheet in 0.5 ounces. I'm going to skip this one because it's obviously what I'm going to start and end with. And the last thing is there's 16 ounces in a pound. Okay, well, I don't know dollars, but I do know that a pound is 16 ounces. So we're going to use that. 1 pound is 16 ounces. Okay. Well, ounces is obviously not what I'm looking for, right? So if it's not what I'm looking for, I drop it low. Again, canceling it out. So ounces, canceled. Boom, done. I'm trying to get from ounces into dollars. Do I know that conversion? No, I don't. But I do know that there are 0.50 ounces for every 1 sheet of paper. And you're like, well, how's that going to help me? Well, we'll get there, right? Because eventually we know that 1 ream equals $4. So that ream is eventually going to get us into that money. Okay. So, sheets, is it what we're looking for? Well, no, it's not. So again, we drop it low. Cancel that out. So we went from sheets and we're going to, well, we can't go $2, but we could go into reams. So we could go into reams. So I know that there are 500 sheets for every 1 ream of paper. All right. Well, the ream is still not quite what I'm looking for. I'm trying to get into money, right? So cancel it out, drop it low. Every time you drop it low, if it's not what you're looking for, it's going to go down to the bottom because you're going from and to, right? Just like a gift tag. You go from something to another something. Well, do I know how to get from reams into money? Yes, I do. So that's a good thing, right? So I know that there are $4 for every 1 ream. Well, is money what I'm looking for? Is dollars what I'm looking for? Yes, I'm looking for price, right? So since I'm looking for price, I'm going to plug it in. Now I can solve it. So it's going to be 1 times 16 times 1 times 1 times 4 divided by 1 divided by 0.5 divided by 500 divided by 100 divided by 1 again. Sorry. Okay. So when I do that, when I plug it in my calculator, I'm going to find that I have 0.256 as my money. But if you think about it, our money does not work like that, right? So we need to round this into something that we would actually use, which would be 0.26. So it's going to cost us 26 cents for every 1 pound. Okay. So that's dimensional analysis, y'all. If you've got any questions, please don't hesitate to ask. Before we finish up, one final thing that I did want to point out, and this is because it is so common in chemistry, I wanted to point it out now because we'll use it later. But one of the most common conversion factors that we use in chemistry is Avogadro's number. This is also referred to as a mole. Okay, so 1 mole is Avogadro's number. 1 mole equals 6.02 times 10 to the 23rd particles. Okay, it's a really, really big number, but I did want to point out that conversion factor. 1 mole equals 6.02 times 10 to the 23rd particles. Okay. Well, y'all have a great rest of the day. Hopefully y'all understand. But again, if you don't, please don't hesitate to reach out. We are here to help you. All right. Bye, y'all.